Okay, today we're just going to take a look at the Axess direct injection system. So traditional retrievable injection systems actually use a side T fitting, which here's an example of a side T fitting. So in this you would have your plug and your injection device go down through the middle. There would be an injection nut in there, and then the injected chemical would actually come in through a side T. So this particular one is actually a threaded side T. These can be in a variety of different types. You can get flanged, you can get welded, MPT, threaded. It just depends on what the injection line is. The disadvantage with this is that is another pathway into the fitting. If the fitting's carbon steel, then whatever chemical you're injecting in there is coming into direct contact with that carbon steel concentrated chemical without process mix. Which in itself can actually be corrosive. The other thing is that a lot of these fittings that are actually welded onto pipes already will be straight fittings with no side T on there. So if you're looking at a flare weld fitting, I'm using a flange in this example, but if you're looking at a flare weld fitting or a butt weld fitting, the chances are that it probably won't have a side T on it. So you can actually repurpose existing Axess fittings as chemical injection systems using our direct injection system. So the basis of this system is that you have a direct injection plug. The direct injection plug basically has a series of one-way valves. So there's two one-way valves that will allow chemical to be injected down through the plug into the line through the injection device, but will not let process return. So when we bleed off the injection line, we can actually disconnect this, we can retrieve this, service anything that needs service, replace a nozzle, change out a nozzle size, etc., clean a nozzle, and put this all back in, all under pressure while the plant is live, without the need to depressurize anything other than the injection line itself. You can keep your process line flowing. So quickly run through, I'll put the plug together and then we'll run through the rest of the equipment and how you would actually install this in the field. So the plug itself looks fairly similar to a hollow plug. It is actually different than a regular hollow plug, and this series of one-way valves will go into here. So I'll just start assembling that. So top seat, push that down in there, and then first poppet, the seat for the second poppet, second poppet, and like a hollow plug there is a replaceable probe packing seal on here. So this is a regular PTFE. You would take that off and replace that, and in a similar way this is a left hand thread and your primary packing seal is here. So when you take this apart you would need to open this up, service that primary packing seal, change out that primary packing seal and replace it. Now you can take this nut off completely. That is going to relieve the pressure on these springs, so just be sure that anything that's taken out goes back into this thing in the same order that it came out. Alternatively, I have seen where people will loosen this plug off, the nut off, and they'll just split the packing seal, lift it off and put a new one on. There is a split on these seals, so you can do that. Preferable method that I would normally use is to take this off and replace it, but either method will work there. I'm going to tighten that down. I'm not going to over tighten this because it's not being put into the line just yet, so I'm not going to compress those seals, but tighten that down, and we'll take a Allen key and just tighten this up. So we're just tightening the two grub screws there to stop this coming apart. Set that to one side. Now that's the complete plug made up. The monitoring, or sorry, your injection device on the end has got a 1/4 inch MPT. This is a short injection coil. It's actually going to be for a flare weld fitting, so it's going to be relatively short and it's going into a small pipe. So I put PTFE tape on there, and make sure that when you put that on, you do about 3 or 4 wraps, and you do it in a way such that when you're tightening this on, that the tail of the PTFE tape is going counterclockwise to the device and doesn't unwrap itself or try to push itself off as you tighten this on. I would get a pipe wrench and tighten this in there. Again, I'm not going to do that just now. This is just a demo, so I'm not going to over tighten that and put this in. This is going to be coming apart. But that would be tightened down in there until it's tight. You then want to get your monitoring device, sorry, I keep saying monitoring device, your injection device, and you want to mark the orientation, because it's important that when this goes into the line that it's orientated correctly. Injection nozzles, if they're right angled nozzles, will be injecting down into the process stream, so you want to go with the direction of the flow. Injection quills, you want it so that this open 45-degree angle or 60-degree angle, depending on the quill type, is facing the flow, so that the chemical comes down and it gets dispersed through this slot. So we want that, mark the plug and orientate that in the direction you want to go, and then it will come through. Okay, just going to look at a product from Axess. This is a direct injection, chemical injection system. Traditional injection system normally has a side tee. This fitting's actually got a side tee on it. I'm ignoring it for the purpose of this video, but a traditional system, you would have a solid plug that goes into the top with an injection up the second set of seals that are below this side tee point. You would then inject chemical through an injection line into the side tee. This could be threaded as this one is, or it could be flanged, welded in through that side tee, and the chemical will go down through the injection nut and out through the device at the end there. Disadvantage with this is you have to have a side tee on your Axess fitting. A lot of these Axess fittings are already in the field, will not have that, and for a flange it's not as big a deal, but for a welded fitting, it's welded to the pipe. You would have to weld a new fitting on with the side tee and all the rest, everything that goes along with that. The other beauty of this system is that in a traditional system, if you've got a carbon steel fitting, your raw chemical is actually in contact with the internals of this fitting, which is the carbon steel. So you've got raw chemical on that, which may itself be corrosive or cause other issues. With the direct injection system, this is 100% stainless or other material, if you would like a different material, all the way down through the system. So it's not, the raw chemical is never actually touching the carbon steel. So, quick rundown of the system. You've got the plug. This is the main part of it. The plug has a series of one-way valves. So there's 2 valves in there, one way. So as the pressure comes in from the injection line, it can inject down into the line. But when you remove that pressure on the injection line, these valves will close up and prevent process coming back up through the plug. What that means is that this is completely shut off. You can disconnect the rest of everything else, and we can retrieve this online as you do with coupons, probes, and this normal side tee injection fitting. So this can be retrieved fully online, fully serviceable online, and the ability to use existing fittings in the field. So I'm going to turn that side tee out of the way, and we'll just ignore the fact that that's on this fitting that I'm using for a demo here. The plug, your injection device will go on the end. In this instance, we're using a quill. This could also be a nozzle, just depending on the application, whether it's process, if it's fluids or gas. On the top of the plug will go the injection adapter. This will screw into the top of the plug. This nut will secure it onto the top of the pressure retaining cover, and that's just preventing anything coming out from here into the cover area, and allowing that chemical to be injected down through the injection adapter and down to the device. So I'm going to quickly just take this apart. There's a few serviceable parts on here. If you needed to replace any of the seals in this, we're just going to go quickly through the components. it's important that when you take this apart that everything's put back together in the same order. But if you were servicing this in the field, typically you're replacing 2 seals. So the first one is internal here. Take this nut off and you have the probe seal. So this is a standard probe seal that you would use on a probe location, an ER probe location, an LPR probe. That seal is compressed down into you. If you take it off the top like I just did, you can do it without letting any of the other internals pop out of here. And you just have to line that spring and that pop it up when you put this back in and screw it back down. The second seal is the primary packing seal. This is the chamfered seal that sits on the internal of the access fit and it seals up the external of the plug. You would just take this nut off and remove that seal and put a new one on. And again, if that can be done without disturbing the internals of this, that's great. If we did want to take out the internals, there's some O-rings and stuff in here, we can do that. And I've got a separate video showing the complete breakdown of that. Right now, I'm just going to pop this back on and tighten it up. I'm not going to over tighten this just now, this is just for demo. I will just nip up those grub screws which prevent anything coming apart here. It's just due to any vibrations or anything within the line. So to make up the rest of the plug, once you have that plug made up, we're just going to run some PTFE tape on the injection device. It's a 1/4 inch MPT. So 3 to 4 wraps going clockwise or counterclockwise depending on which way you look at it. If we say it's a clockwise thread, that tape's on counterclockwise. That's just so that when you tighten this down it doesn't bunch up and it helps seal that nicely. I would put that pipe wrench on there and just tighten that down just to secure that and prevent any leak from the MPT. Lastly, before we go and install this into the fitting, I want to just mark the orientation. This is a quill, so a quill you want the process to come along and hit this angled portion, and then as the chemical comes down through here, it's going to be dispersed through this slot and dispersed into the line. If this was a nozzle, again, we want this with the direction of the flow and the nozzle pointing down with the flow, so it would spray out into gas. So now that's done, put a little bit of grease on the external threads here and we'll tighten this down into the fitting. So this is a standard parallel thread, so this is going to be 14 turns, and we mark that on the top of the plug. The reason being, when it comes to retrieving these online, it's good for the technicians to know, or it's vital for the technicians to know, if this is an Acme thread fitting, which would be 8 to 9 turns to fully release the plug, or 14 turns, so it allows them to count the turns on the way out. So we mark that on the top of the plug there, 14 turns and 9 turns. I'm going to tighten this up, so an 1 1/8" wrench. If this was online, you'd be doing this with a tool, and then when you take the tool off, we can just orientate that to get that in the correct direction for the injection device. So now that's in there, that's all sealed up. The one-way return valves will prevent any process coming up through there, and we can go and start to put on the rest of the injection components to complete this. So it's a 1/2 inch MPT at the top of the plug. Again, I'm going to put some PTFE tape on there. And I'm also going to tape up the opposite end of this at just now, because it's easier to do when this is loose like this than to do it once it's attached to the fitting. And then there's also the nut here for the external of the injection adapter. Okay, so injection adapter can go down at the top of the plug, and at this point I don't want to disturb that plug, I don't want to upset the orientation, so put the 1 1/8" wrench back on and I'll tighten this down into the top. Okay, you want to do that just so it's tighten up the seal, and then we can put on the pressure retaining cover. So the cover has an O-ring in the bottom there. It's designed to seal on the top of the access fit, and these are available in a couple of different types. We have, this is the traditional one, and there's also a Janus one which will actually have an extra 2 seals to provide a better sealing against the access fitting. But slide this, you know what, I'm going to stick it on. Now it's important that you put the gauge on at this stage before this is installed. The reason being that you cannot turn the gauge with the injection adapter nut on there. So get the gauge on, tighten it down and orientate it externally, and then we can slide this down on there onto the fitting. Spin that on, and this would then be tightened down with a C-spanner into the grooves. So with that installed, we can then put on the injection adapter nut. There's an O-ring seal on the internal of this. I am going to just put a little dab of grease on that just to make that slide down over the top here a little easier, and pop that down into the top and tighten that down into the top of the pressure retaining cover. After that, we have the bleed port on the cover. The bleed port is there to bleed off any external or any internal pressure that may have built up in the cover. Under normal operating circumstances it shouldn't be. This is a secondary isolation, but it's there during servicing if required. So tighten that down, and then we just want to make sure that that bleed is actually shut. The last part of this is the needle valve. This is a 1/4 inch MPT on the top. I'm using a 1/4 inch needle valve here. It's got a flow direction, so we want to put that with the way that the chemical would flow into the line. Not all needle valves have that, but this one does. So we'll pop it down onto there and tighten it up. And then this is now ready to be used. So this is closed up. Connect up your injection line, and then this would be opened up, and that will allow your injection pump to pump pressure down through this, down through that double valves, and in through the injection device. Okay, to remove this, we'll take a look. Everything would be done in reverse. So we'll close this up, bleed off the injection line, bleed all the pressure off, get all the chemical out of that, and then we can start to take this apart. So when we first go up to the access fitting, we want to check in this gauge if there's any pressure. If there's no pressure showing, then we can start to take this apart. Still open that bleed port just to check in case there's an issue with that gauge. Okay, there's no pressure behind this. This one's all offline. So we're just going to continue and actually take this apart now. So take the MPT needle valve off the top, put that to one side, and then I would remove this bleed port. If you can get a wrench in there, you could take this apart without removing the bleed port. It's going to be easier just to get this out of the way. So take that off. Any of these threaded fittings, we would replace the PTFE tape, clean that up, get it all off there cleaned up, and before it goes back on. All this stuff is hand tight because I've just been doing this as a demo, but normally you would need wrenches on this to remove it. But swap that off and out the way, give it, pop it off the top there. So that's the injection, external injection adapter nut. Take that off. If we need to replace O-rings, there's an O-ring seal and a backup seal in there. That can be replaced now. And then we will remove the pressure retaining cover. Even though we know there was no pressure in this, we just take care. The reason we're taking the cover off before we remove this adapter is that this adapter is threaded into the top of the plug with an MPT. Now, depending how tight that was, if we started undoing this, there is potential it could start to unscrew the plug. So we want to just take that off and get a wrench on there to keep that plug in position whilst we unthread the adapter. The adapter off here and to one side, and now we're ready to do the retrieval of this device. This is offline, so I can actually go and track that and start taking this out. If this was online, we're doing this with retrieval equipment. You would crack the plug, just to get it to move, and then we would continue normal retrieval. And there's a whole bunch of procedures depending on what tool's being used to do that. I'm going to just spin this out by hand, and once again, we have this marked on the top of the plugs now. All the newer plugs should have this marked on the top, whether it's 14 turns or 9 turns, 8-9 turns, depending if it's a standard threaded fitting or an Acme thread. So remove that, pull this out. We go about servicing the seals, replace the quill, replace the injection nozzle, whatever it is that is being done on this, and back to the install again.